Okay, guys, here we go. This is example one for my next little lesson here. And I'm going to finally show you a problem where the first number is not a 1. Also, you'll notice these are already written in equation style. So, all of your problems, just to get used to the formats, sometimes it'll be written in function style. This example is written in equation style. So, they want me to solve. So when they say solve, that's a very broad term. It means find out any value you could plug in for x that would make this a true statement. Now here's the thing. What do I want you to get from example 1? There can be fraction shelf numbers. We haven't seen that yet, but it's because of this guy. And you can have complex number answers. That means there could be I numbers in the answer. Now, I numbers are actually really easy to spot when you do the work. So let's begin with, what are my possible shelf numbers? So you say plus or minus 1 or 5. But here's the thing. This number here also contributes to this concept. See, every time we've done a problem so far, this number's been a 1, which means there's a 1 in the bottom. But since there's a 3 here, you have to ask yourself, what goes into 3? 1 and 3 go into 3. So when I've been talking to you guys about this thing called the rational roots theorem, I've been using that term, rational roots theorem. We've never had a bottom part to it because that's always been a 1. So you'll see in my next two examples, I use this. But what does it really mean? It means we could have a positive or negative 1 over 1 or 5 over 1. Or my shelf number might be 1/3. Or my shelf number could be 5/3. So when I do synthetic division, I don't always get to start with a whole number. Sometimes I might have to use a fraction. Yeah, I know it's not we're like, woo, great, that sounds totally fun. No, but I mean, that is the breaks. That does happen. So here we go. I want to show you what it looks like when we do that. So I'm going to do synthetic division. It's in the right order. It is. I know that I should find 3 solutions for this equation because they told me to solve. I'm going to bring the 3 down. This is the first time I brought down something other than 1. And I've got to pick a shelf number from this list. But I don't want to just guess and hope I'm right, especially if I have to guess a fraction. Ugh. So here we go. Once again, I'm going to use my graphing calculator to help me out. I'm going to turn it on. And when I turn it on, I'm going to go to mode. And just so you know, I'm going to go back to classic mode this time. In case anybody out there does not have MathPrint as a capability. You can switch between the two. In fact, you know what? You figure out what you like the best and then use that. That's okay by me. So I'm going to use classic mode. I'm going to quit that screen. Right above mode says quit. I'm going to go to y equals and I say, wait, that's from my last thing I did. So I'm going to clear it out. And I'm going to enter in this new guy. This new guy is 3x to the third minus 7x to the second plus 17x minus 5. And here we go. I'm going to hit graph. So here, I'm going to get a little closer so it's a lot. There we go. Let's see what it looks like. And remember, if you forgot to zoom standard last time, you're in trouble. Now, wait a minute. I'm supposed to have 3 answers. I only see one thing. Well, here's the deal with this. This graph is a third power polynomial. So it's supposed to go up on the right side and down on the left. Maybe this thing goes over here somewhere. Maybe it goes off the screen somewhere. Or maybe we have I numbers or complex number answers. Here's how we play this out. That intersection with the x-axis appears to be between 0 and 1. Hey, you know what? That's my only choice in my list of possible roots between 0 and 1. So I'm going to go second, calculate the value. At 1, now to enter a fraction on this, I just use division. 1 divided by 3. And look, it types it out for you like a fraction. I'm going to hit enter, and guess what? And by the way, whenever you enter a fraction, it'll convert it to a decimal. I don't know why it does that, but it does. So 0.3, which is 1/3. So guess what? I'm going down here. 1/3 is the number I'm going to use in synthetic division because I do not see any other choice. Let's multiply 1/3 times 3. Well, that's easy. 1/3 of 3 is 1. Add down. I get -6. What is 1/3 of -6? I think it's -2. I'm going to add down. I get 15. What is 1/3 of 15? 1/3 times 15 would be 5. And then I go, woohoo, totally cool. I got myself a 0. So that is one of my answers. One of my solutions to this equation is 1/3. I have 2 more to fill in the blanks. I don't know what they are going to be, but my guess is they're going to be complex numbers. Why? Well, I'll explain as I go, but let's walk it down. I had a 3rd power problem, so now this is going to be a 2nd power situation, and that looks quadraticic. It really does. So I have 3x squared minus 6x plus 15 equals 0. Now, do you guys notice this? There is a GCF involved here. When you have a GCF in an equation, you can take it out. It will not change your solutions for x. It won't. No, no, no. I am wagging my finger. I am going to take out the 3. Check this out. Here's why it doesn't really change things. I take out the 3. What's the benefit? I have much tinier numbers to work with. Me gusta tiny numbers. But here's why. If I divide this by 3 and I divide this by 3, I am not breaking any rules. That is a totally legit statement. Over here, they cancel. Over here, what's nothing divided by 3? It's nothing. So I end up with x squared minus 2x plus 5 equals 0. I can solve that using quadratic formula, and the numbers are tinier. Now, here's the thing, though. I wanted to show you this. When you use quadratic formula, negative b plus or minus square root of, be careful, b squared, -2 squared, means -2 times -2, which I know is 4. But be careful on your calculator. I'm going to quit the screen here. Watch this. -2. I just entered in -2 to the power of 2. It's going to tell me the answer is -4, and I know that's not true. When you are going to take a negative number to a power on these calculators, you've got to put it in parentheses or it'll get it wrong. Better yet, here's what I say, better yet, do it in your head. Negative b plus or minus b squared minus 4ac all over 2a. So we go 2 plus or minus the square root of, and then this whole chunk of junk, the discriminant, this number inside here, turns out to be -16. And then I say, whoop, I say, wait a minute, that's the same as what they used to call me in the 4th grade. That's 4 eyes. 4 eyes. Get it? It's a joke. 2 plus or minus 4. It's a horrible joke. Okay, so here's my question to you. Way back when, I think it was lesson 3 or unit 1, video 3, I had you guys do this type of stuff at the because we can reduce this thing. Let's reduce it. What do we get? We get 1 plus or minus 2i, because 2 goes into all three. You don't get to reduce if only these two guys have something. You don't get to reduce if only these two guys. It's got to be all three. It's got to be the triple. It's got to be the trinity, the threep. I can't, trifecta. So what do we get here? Hey, when I go to solve this equation, 1/3 was one of my answers. In fact, that's the only answer that is called a real solution. These other two answers, 1 plus or minus 2i, 1 plus 2i is one of the answers, 1 minus 2i is the other one. Those make up my three solutions because I'm supposed to have three solutions. But two of them happen to be complex. Now, how do you recognize that? Let's go back here. When you look at a graph and you know there's supposed to be 3 points of intersection and you only see 1 point of intersection, chances are you're going to have a complex solution in that question. Let's take a look at the next example. I got 2 more to go. So here we go. First things first, I like to clear my screen. I like to go back to y equals and clear stuff out. If you haven't done it in a while, Zoom standard. Make sure you're starting fresh every time. Looks like I got a little goober there. Okay, so anyway, here is my next example. Now this is an equation, but what am I trying to get at with, with example 2? What am I trying to get at? I want to cover all the bases with you guys. I want you to remember that to solve a polynomial equation or to find x-intercepts, whatever they're talking about, you got to set it equal to 0. Now, the other thing I want you to get out of this is make the highest power positive. So look at this problem, this equation. The highest powered thing in that whole deal is this guy, and he is currently negative. I want to move him to the other side, and that will make him positive. I want to move this guy to the other side. I would have to take away this guy to move him. I would have to add this guy to move him. But if I do that, the result should be this. I get everything on one side, it equals 0. That's what I got. Now, this guy, once again, that's not a 1, that's a 2. So my first step is use the rational, and I'm rational roots theorem to give myself a starting place. Plus or minus, what goes into 28? 1 does, 2 does, 4 does, 7 does, 14 does, 28 does. Ugh, that's a lot of stuff. What goes into 2? 1 and 2. Okay, so here's the deal, guys. I know that any of these could be a possible choice, but what about this? What about like 1/2? What about 2/2? Wait, 2/2 reduces to 1, so I don't need to count that. So 1/2, and then there's only one other combination here that isn't already, you see it? Do you see it? 7/2. So I am now going to say unto myself, I have already set it equal to 0 and made the highest powered thing positive all in one shot. Good for me. Now I need to solve this thing using synthetic division. Bringing down the 2. Oh, I need some more room here because I have to show you my shelf. But before I do anything, now it's time to go back to y equals and graph this. So I'm going to say 2x to the third. Where are we at? 2x to the third minus 7x to the second. Sorry, I'm in the way with this. I'm trying to, plus 8x minus 28. All right, so I have it entered in. There it is. Make sure you're matching up with me. Okay, I'm going to hit graph. Let's see what happens here. When I hit graph, well, how suspicious is that? It looks like it crosses between 3 and 4. You know what? I know many numbers. There are infinitely many between 3 and 4. But this guy seems to be the one that they want me to use. Because the rational roots theorem says, if you're going to find any kind of shelf number, you're going to find it by looking at the combination of this and this. Okay, so I have my graph. I'm going to turn this off now and get it out of my way. Because if I am correct, then 7/2 is the dude I got to use. And I go, what's 7/2 of 2? So, you know what? 7/2 of 2. Cross cancel. That's a 7. Add down, I get 0. That's okay. What's 7/2 of nothing? Nothing. Add down, I get 8. What is 7/2 of 8? Well, cross cancel. I mean, you could do it on a calculator, but really, these are not brutal numbers to work with. But I wanted you to see something that ended like this. So let's see, 2x squared plus the ox plus 8 equals 0. So I am now going to take this guy here and do the work down below. So I'm going to rewrite it for you. 2x squared plus no x's, so I'm just going to go right to there. Now, see this guy right here? I could cheerlead this thing. I could move the 8. I could. Take it away. Take it away. Take it away now. And I'd get 2x squared equals -8. I could then divide by 2. I could. And I'd get the squared thing alone. I want the squared information by itself. What's it going to equal? It's going to equal -4. And then I could say, what do cheerleaders do? They root. And I get x equals plus or minus 2i. 2i. Bam. So that's one answer, 2 answers, 3 answers total. So the solve, it says solve, I just did. I get x equals 7/2 and plus or minus 2, crap, 2i. That is the worst looking I, but you know what I meant. Okay. Oh, and you can't even see what I'm writing. That is the worst looking I. I don't know what happened to that thing. There, even that looks crappy. We got one more example. Why do we have one more example? Because this is my last example. Now, here's the thing. It's a 4th power problem. It is. And this last example has a little bit of everything we have talked about up to now. So, what I'd like you guys to do is see if you can get the answer to this all by yourself. Pause the video right now and go through all the steps that you have been taught and see if you can get it. Okay, so pause it. Okay, so you should be back from the pause now, or you never paused it and you said, I'm not doing that. You can't make me, you're not here. I'll go, okay, fine, that is true. So anyway, see this guy? What was your first move? You should have moved this over. You should have subtracted the 21. 21. And that would have given you, I got to write this out, 4x fourth minus 7x cubed minus 25x squared plus 49x minus 21 equals 0. And then I would say, well, I'm going to have to use synthetic division twice to do this, so I might as well get it ready to roll. I might as well get everything ready to rock. I'm going to bring down a 4. I'm going to have to pick a shelf number twice to do this, but I don't want to just pick any shelf number. So what are the possible ones that would work for me? Plus or minus 1, 3, 7, or 21. And then what would be the bottom part? 1, 2, or 4. Ew. So I might have 1/2 or 1/4, or 3/2 or 3/4. 7/2, 7/4. I have 21/4, 21/2. There's all kinds of crappy possibilities for this thing. So I do not want to just guess. I'm going to go back to my calculator. Now, I'm going to go y equals, and I'm going to clear this out. This is, and I'm going to say 4x. Okay, I'm just going to put it down and do it. 4x to the 4th minus 7x to the 3rd minus 25x to the 2nd plus 49x minus 21. And let's graph it. Let's see what it looks like. And hopefully when you graphed this thing, you saw this, which I was trying to fool you on. I was trying to fool you a little bit and see if you would go, I wonder what's up here. Now, here's the thing. That looks like a 1. So I would be instantly drawn to the easiest number and say, 1. So I'm just going to jump on it and try it. If I use 1 here, 1 times 4, I get a -3. Ding, ding. I get another -3. I get -28. -28. Oh my gosh, what is that? That's 21. 1 times 21. There it is. Bam, I found it. So I go, cool. One of my solutions. Solve. You better believe it. I found one of the answers. I have 3 more answers to find. But if you look at that, it almost looks like a bounce. Almost looks like a bounce. It seems to poke through that x-axis just a little bit. So guess what? I'm going to zoom box. I want to go in and find out what's going on there. So I'm doing zoom box. I'm going to go over there, and I'm going to take charge. Let's see what's inside. There's the bounce, I think, at 1. But it's not a bounce at all. That dirty bird. Look at that. That's not a bounce. So that's the 1. Let's make sure. I'm going to go second, calculate the value at 1. I'm using all my tricks. Yep, there it is. So guess what? This is some number less than 1. Look at our possibilities here. What's a number in here that's slightly less than 1? I think 3/4 is the dude. So I'm going to just check it. I'm going to go second, calculate the value at 3 divided by 4, 3/4. And I'm going to say, there it is. Woot, woot. So I'm going to now say 3/4 is the next number. It is totally 3/4. So let's do this. I'm going to bring down the 4. What is 3/4 of 4? 3/4 of 4 is 3. Oop, there's my 0. 3/4 of nothing is nothing. That's -28. 3/4 of that is -21. And I add down, I get 0. So guess what? 4x squared plus no x's minus 28 equals 0. Wait a minute. Let me go back to that picture. I'm going to zoom standard. I'm going to zoom standard and get out of that box I was trapped in. See, just because I had to show you problems that have I number solutions to them doesn't mean everything does. This clearly has 1, 2, 3, 4 points of intersection. So there are 4 points of intersection, which means I'm going to find them right here, and they are not going to be I numbers. There are 4 points of intersection. I will not find I numbers here. Here's the big thing. Complex numbers do not cross the x-axis, ever. That's one thing I wanted you to get out of this. So if you see that you have all 4 intersection points, it means you're not going to get any I numbers on this guy. So let's do it like we did the last one. We're going to cheerlead. 4x squared minus 28 equals 0. Ready? Okay. Let's move the 28 because I like to move it. I like to move it. I'm going to get 4x squared equals 28. Es la verdad. Vamos a dividir. Dividimos. What is that, 7? 28 divided by 4 is 7, right? So I go root. Ready? Okay. X equals, I'm going to just write my answers here. X equals plus or minus rad 7. So that's 1, 2, 3, 4 answers. That's what I was supposed to get. That's a solve, baby. That is a solve. So just for kicks, one last thing. I'm going to go second, calculate the value at square root 7. And see, it did that. See, I'm trying to get an example that does every weird thing that you can possibly run into. What does it mean when your calculator says, "ee"? That just means it doesn't know how to say 0. That's what it means. That's what it means. Because it's trying to say 1 times, it's trying to say 1 times 10 to the negative 11th, which is a super tiny baby number. Your calculator does not know how to think. But guess what? That's pretty darn good. Pretty darn impressive, knowing how to use so many things. Remember, y equals. We enter things there. That's where we enter our stuff. Whether we're in, I'm going to hit mode, classic or math print, that's up to you at this point. But I know that I can zoom things. I can zoom box. I can zoom standard. Zoom in and out, zoom square, we'll talk about that down the road. But basically what you end up using the most is zoom box, zoom standard, and when we get to the trig, zoom trig. Those are your big heavy hitters in the zoom menu. Now, trace, remember that's just an estimator. I can move that little spider on the web there. But calculate, there's all kinds of cool stuff there. And we'll talk about it as we go through. And then, of course, graph is our guy that draws the graphs. But right above graph, hey, you can't hurt the calculator. I'm going to hit second graph, and I get this table. So it means when you can look at all these different values, but they're whole number input, and we're not always using whole number input. But there you go. There's all kinds of stuff to play with on the calc. But now you know quite a few things you can do with it. All right, we'll talk about it later because that is all I needed to show you. So I'm going to turn this off, the calculator it is. And then here is what I want you guys to do. And I wrote them in equation form this time. There's 5 questions there. Solve the following polynomial equations. Do not give me decimal answers. If it's fraction, you write a fraction. If it's a radical, you write a radical. Pause it, take a picture of it. Here comes the answer key. If you do these correctly, there's the answers you should get. And you'll notice I don't have any decimal answers there. Okay, and 2 of them will result in complex numbers. It can happen. And these ones don't. All right, good luck. See you on the other side.